What's going on, guys? I'm here to tell you about what we'll be doing to show you our understanding of rotation. So we will discuss rotation of an object and show an example of how to find the velocity of that object in rotation after a certain distance. We will then show how to find the kinetic energy needed to move the object the specified distance.
So we're going to find the rotational energy of this bowling ball by rolling it 11 meters per second at each other at 10 pounds. So here we go.
In our first scenario, we're going to do a bowling ball rotating one full rotation. The radius is 11 centimeters and the distance equals 2 pi r. So then we put in the radius, which equals 0.11 meters, and that goes to 0.22 pi, which equals about 0.691 meters. In the second scenario, we're going to have the bowling ball rotate only 100 degrees. And so we use our kinematic equation over here to put that in. And so we go 100 degrees equals 1/2 the angular velocity times time, or multiplied by time, which equals 100 is the angular velocity. And so the velocity back over here, we plug that in and we put in the radius as 0.11 meters and the degrees as 100 degrees, and the velocity equals 11 meters per second.
Okay, in order to find the energy of the ball rolling over, you need to have the velocity of the center mass along with the angular velocity, and they both have a common radius, and then the radius, as mentioned, is 0.11. So in order to find the energy, we need to find the energy of the center mass plus the energy of the bowling ball rotating. So the equation of the center mass is 1/2 times mass times velocity squared, and then the rotation of the energy. In order to find that, we need to find inertia, which inertia, the equation is 2/5 times mass times radius squared. And we need to find the angular velocity. The angular velocity is the velocity of the center mass over radius, and we were able to figure that out in the other equation, which is 11 meters per second. So we get 1/2 mv squared plus 1/2 times moment of inertia times angular velocity. So as we do common variables, we get, with the numbers plugged in, moment of inertia is 2/5 times 10 times the radius square, which we get 0.0484. And if we plug that into the energy equation, we get 1/2 times 10 plus 0.0484 over 0.11 squared times 11 squared, which is the velocity of the center mass squared. And then we end up getting 847 joules as our answer.
In summary, if you put work into a rotating object, the object will start to spin. And when that object is spinning and all of its pieces are moving, it has kinetic energy. Moreover, to find the rotational energy, we need to convert our concept of linear kinetic energy to the concept of rotational kinetic energy. We did so with the example of the bowling ball. To find the rotational energy of the bowling ball, we need to use the equation kinetic energy equals 1/2 times mass times the velocity squared plus 1/2 times inertia times the angular velocity squared. And in order to use this equation, we needed to find the inertia, the velocity, and the angular velocity of the bowling ball. And all this work led us to the amount of rotational energy needed to move the bowling ball.